There's another property that we can look at in terms of its periodic nature on the periodic table and see if there's a trend, and that's electronegativity. Electronegativity is the general tendency to draw electrons toward yourself. If you're strongly electronegative, then electrons move towards you in a bond. Now, electronegativity isn't something that we can do an experiment to measure. That is, we don't have, as in ionization energy, an obvious experiment. Have the atom, pull off an electron, see how much energy that takes. For electronegativity, what we do is we look at a bunch of bonds. You take an element and you see how it bonds to other elements. And you see, are those bonds polar? Are the electrons in that bond spending more time around one atom than the other atom? If one of the atoms tends to draw the electrons towards itself, then that atom is more electronegative. So you can do this by cataloging hundreds of bonds between different elements and seeing which elements tend to draw the electrons toward themselves. And it does go in a trend. You find that electronegativity increases as you go from the bottom corner to the top corner of the periodic table. And in fact, francium, the least electronegative element, and fluorine is the most electronegative element on a generally increasing trend across the periodic table. So if you look at a bunch of bonds, you can say the polar bonds, the ones that have electrons separated, spending more time around one element than the other element in the bond, those polar bonds tend to be quite a bit stronger than the bonds where the electrons spend time around both atoms. And you can judge the strength of the polarity. Polarity increases, in fact, it can increase so much that the electronegative element actually ionizes the other element. It takes the electron to itself altogether. Then you're held together by the extreme of polarity. One negatively charged atom being attracted to a positively charged atom. The electronegative element has completely captured an electron from the other element. That's called an ionic bond, and what holds it together is a Coulombic interaction, the positive attracted to the negative. You can catalog a continuum of bonds by looking at differences in electronegativity. The greater the difference, the more ionic or the more polar the bond, and the stronger the bond. So high ionic character is bonds where the difference in electronegativity is greater than 2 units, like sodium chloride. Sodium having electronegativity of around 0.9, chlorine having electronegativity around 3. That's a big difference, and chlorine ionizes sodium to form an ionic bond. That's the strongest kind of bond you can have. You can have intermediate differences in electronegativity. Here's partially ionic hydrogen chloride, where the difference is modest. That's still a polar bond and still rather strong. If you look at lower differences, so here's a covalent bond where the difference in electronegativities is rather slight. In fact, for homonuclear, chlorine-chlorine bond, there's no difference in electronegativity. That's perfect sharing of electrons. But for small differences in electronegativity, you'll have covalent bonds. So covalent, partially covalent, ionic, very ionic, separated in polarity. The more polar, the stronger the bond, and I can look at that based on electronegativity, one of our trends in periodic properties.